So, yesterday you guys took a quiz over the 4 ways to show that triangles are congruent. And I told you last week we're going to learn a 5th way. That's what we're going to talk about today. So the new one is called the hypotenuse leg congruence theorem. Just like all the other ones, this one has a shortcut name too. So instead of writing the words hypotenuse and leg, we'll talk about a shortcut. You don't need to write this down. We already went over this during the warm-up, but just in case you weren't quite with us just yet, you need to remember that in a right triangle, we have the right angle right here. The two sides that make the right angle are called the legs. The side across from the right angle is called the hypotenuse. You have to be able to distinguish if we're looking at a leg or if we're looking at a hypotenuse today. If you cannot tell the difference between those, you're going to struggle. So if you're still struggling, you can go ahead and write this. This is a leg. This is a leg. This is a hypotenuse. So if you want to include that little diagram, that might be helpful moving forward. So anytime we talk about it from now on, we'll write HL, but H stands for hypotenuse, L stands for leg. So this theorem, which I do want you to write in your notes, states that if the hypotenuse and a leg, so we need one hypotenuse, one leg, and one right triangle, needs to be congruent to a hypotenuse and a leg in a second right triangle, then the two triangles are congruent. So we talked about last week, if you have an angle, then a side, ASS, that does not work. This is the only case where it does work. If it's a right triangle, then it works. But you still can't write ASS. You have to write HL. The first two I'm going to do, you can just watch. After that, you're going to have to put some of them in your notes. This says, does the diagram give enough information to show that the triangles are congruent? So, in part A, do you see how I have a right angle? If you have one right angle, and they're formed by two intersecting lines, you actually have two right angles. If the line's extended, you'd actually have four right angles. So, we do have two right triangles. This segment is in both of the right triangles. Do you all see that? Now, the line that I just traced in red, is that a hypotenuse or is that a leg? Hypotenuse or leg? A leg. So we have a leg in each. Then we have this side over here. Is that a hypotenuse? It is. So do we have hypotenuse leg? Nope. Yes, so this would be, does the diagram give enough information? So we would say yes. And then you could say because of HL.
So it's supposed to smell more?
I don't know.
If you do, I hope maybe that's good.
All right, part B. We still have the right triangles, right? We have these matching legs because it's in both of the triangles, but do we know anything about the hypotenuse? No. So this one's a no. And if you have to explain it, I would say not enough info. Or you could say missing a hypotenuse. All right? As you're drawing number 2, I'm going to help you figure out what this is saying. So this is saying that QS bisects RT. So if RT is bisected, then these segments are congruent. So you can just go ahead and label those congruent. And then just, you don't need to write that. So take a second, draw these triangles, and then now it's asking us, does HL work? So yes, it's an HL, or no, it's not an HL, and why? The first thing you want to look for HL is, are we even looking at right triangles? So number 1, is this a right triangle?
No. Yes.
This one is. Is this one?
No.
No, it looks like one, but remember, it looks like one or it looks like that's what's happening. That's not a reason you can use in geometry. So this one is a no. And to explain, I would just say not a right triangle. All right. And usually when one's a no, that means the other's a yes. But let's just double check. So do we have two right angles?
Yes.
Do we have a hypotenuse and a hypotenuse? Do we have a leg and a leg?
Nope.
So this would be a yes. And I'm just going to put yes, HL. So, does the diagram give enough information to prove that the triangles are congruent? If so, state the postulate or theorem you would use. So this is like the back page on the quiz or the reviews that we were doing last week. So is it one of the things that we learned? So I will list them all. We have side, side, side. We have side, angle, side. We have angle, side, angle. We have angle, angle, side. And the newest to the group is HL. So in number 3, anyone have any thoughts?
Sorry.
Well, I'm seeing right angles. Anytime you see right angles, I would check HL first. So do we have the H?
Yeah.
Do we have the L? Yeah, so this one is HL. Sometimes the right angle is just a like congruent angle. It doesn't quite fit into HL. Maybe it's side angle side or something. So you can't automatically say HL, but it's a really good starting spot on those. All right, number 4. Do you remember what I know about these angles in this situation? These are absolutely right. These are vertical angles. So now I have angle, then I have these sides, then I have these angles. So which one is this one? Angle, side, angle. Good. All right, number 5. These arrows means that the lines are parallel, and we have a transversal here, which gives us opposite interior angles congruent. So now we have these angles, and we have these angles. The arrows are not congruent. That's not yours. The arrows don't mean congruent. However, this segment is in both triangles. So I have these angles, and then these sides. So what am I looking at? The side's not in the middle. Angle, angle, side. Yep, order matters on the angle, angle, side one. So be careful. All right, anyone have any thoughts looking at number 6? This is a side, side, side. Yeah, you can see that this side is in all 3. Side, side, sides tend to be the one that everyone does the best on. And then number 7, I have these angles. So side, angle, then these sides. So what am I looking at on number 7? What do I have in each triangle? Side, angle, side. Good. We have the angle in the middle of the 2 sides. All right, that is actually it for today. I'm going to put the summary right on this slide because I think this is going to be really helpful as you work through your homework just to see like an example of each type. So today we learned HL. All right.